This is Euclid Book 3, proposition number 28, and we're going to start here with two equally sized circles. That means that the circumference of each circle is going to be the same size as the other. Okay? We're going to start out with two circles here. We got A to C to B to G. That's the first circle. And then we got another circle over here. And we got one that goes from D to F to E to H. And then Euclid says, what I want you to do is I want you to draw a line called AB. Well, here's AB right here. Okay? Here's AB. And then he says, in this other circle, I want you to draw a line called DE, but DE has to be the same length as AB. Okay. We do this. Now, what Euclid wants you to do is he wants you to have a segment of a circle, which this is the segment of a circle here from A to C to B, and this segment right here from A to C to B, which is cut off by AB, is going to be exactly the same size. There's going to be the exact same area in this as there is in D to F to E. Now keep in mind on D to F to E that DE cuts off this segment right here. So the area inside of this segment of DFE is going to be the same as ACB. And the thing is that the other segment, which is from A to G to B, this segment right here, which is cut off by AB, this area inside of here is going to be exactly the same amount of area as D to H to E. And keep in mind that the segment DHE is cut off by DE right here. Okay? So the area inside of here is going to equal the same area inside of here, and the area inside of here is going to equal the area inside of here. How do we prove this? Okay. Euclid wants you to draw lines from the center of this circle, which in this case is K. He wants you to draw lines from K to A, and again from K to B. Now, because all radii of a circle are equal, we already know that K to A and K to B, these two lengths right here, are going to be exactly the same size. Now, we can take this one step further. The center of circle DFEH, okay, is L. There's the center right here of this circle. Now, if we draw a line from L to D and let a line from L to E, we can automatically say that all radii of the circle are equal, so therefore the length of LD and the length of LE are exactly the same size. But we also said that this circle here is exactly the same size as this circle here. The same amount of area in here is the same as in what is in here. Therefore, we can now say that the length of K to A is the same length as the length of L to D. Likewise, the length of K to B is exactly the same size as L to E. And we already established in the first part of our proof that the length of AB and the length of DE are exactly the same size. So, what are we going to do? We're going to go back to Euclid Book 1, proposition number 8, and we're going to declare that angle AKB is exactly the same number of degrees, this angle right here, AKB, is the same number of degrees as angle DLE. The number of degrees in here, same as here. Okay. Now, if equal angles stand on equal circumferences when they are at the centers, then we can then say by Euclid Book 3, proposition number 26, that the circumference, or actually the segment here, of AGB, this segment right here, equals DHE. This segment right here equals this segment right here because of Euclid Book 3, proposition number 26. Now, we can then take this one step further. We already know that circle ACBG is comprised of two circle segments. The first one being A to C to B, the second one being A to G to B. So if you add segment ACB and AGB together, you're going to get the circle ACBG. Okay? Likewise, we already know that if you add the segment D to F to E, this circle segment right here, D to F to E, and the circle segment D to H to E together, you're going to get circle DFEH. Pretty much a given there. So we're going to subtract from this whole circle here, ACBG, we're going to subtract segment AGB. And from this circle right here, which is DFEH, we're going to subtract segment DHE. What do we have left? Well, equals taken away from equals will leave equals. Therefore, the segment A to C to B is exactly the same size as segment D to F to E. ACB, DFE, these two segments here have the same amount of area. And that's what Euclid wanted you to prove. I will tell you more in a future video, so stay tuned.